Alright guys, so these notes are titled Which Way is Best. We learned two different techniques to solve systems. Today is going to be sort of a review of both, because what the state test is going to do is they're not going to say, hey, use this. They're going to say, just solve it. And you're going to have to figure out which one of the two that we should use. Speaking of those two, why don't we list those two down here on our learning target? What are the two different techniques that we learned this chapter? Anyone remember? Well, one of them is elimination. That's the one that we just finished. And how about the other one? Substitution. Now there's a third technique, and we always started off with that. That's graphing. So would you guys, one more time, graph these two for me, see where they meet, pause the video, and then unpause it after you've had a chance to graph it and assess yourself. Hopefully that was enough time. Our slope for this first one was 1/2, and my y-intercept is 0, -1. Look at yours. If it doesn't say that, yours is wrong. I see a lot of people that just leave it as -1. It needs to say that. The other one is 1/4 and 0, -4. Again, if you don't have 0, -4, change it so it actually says that for me now. Okay, so now let's graph both of these. My red one starts down here at 0, -1, and it's going to go down 1 and over 2. I'm assuming if you messed up, that's probably where. And then the blue one starts down here at -4 and goes up 1 and over 4. 1, 2, 3, and 4. And I can easily see where those two meet. The correct answer looks like it is at, is it 4, -3? So down here where it asks for our solution, we want to say 4, -3. So now that we know both techniques, I want you to get good at it. The state test, like I said before, will not say solve this system using substitution. They will just say solve this system algebraically. I want you guys to look at a couple of different looking systems today to hopefully review and get yourself a little bit more comfortable solving them. So on the next page, I start to say when I use which one here. I say my rule of thumb is usually if the terms are lined up in the system, use, what I mean by lined up is this one right here. So which one do you guys think you would use for example 1? And they're all lined up like that. Hopefully you're saying elimination. So when they're all lined up nicely, we're going to use elimination. So that being said, let's do that real quick here. And why could I draw that line across already? What's so special about this specific system? Well, I already have an opposite amount of one of those variables. Which one is it? It is that y. I have a +10 and a -10, so now when I add them up, I end up getting 0 y's. I get -6 plus 4 is -2x is equal to -14 plus 6 is -8. I divide both sides by -2, and I end up getting x is 4. All right, now let's plug that back in. Which one of those looks easier to you guys? I would probably say that bottom one, that 4x plus 10y is 6, and then I would plug that 4 in right there to get 16 plus 10y is 6, minus 16 on both sides, and I end up getting 10y is -10. So y is -1. And when I write my coordinate, I'm going to write 4, -1. Okay? So when it's lined up, like we just had it, we're going to use elimination. So how about substitution then? When was substitution better? If you think back to the beginning of this chapter, that's when we did substitution. Everything that was going on there had a variable solved for. So if one of the equations in the system has a variable solved for, use substitution. All right, so let's take a look at one where a variable is solved for. We're taking a look down at number 2 right here. You guys remember this one where I would say write one of them off to the side. So which one would we write off to the side? Well, obviously the top one, because it's solved for y. So we're going to do substitution, like I said. So we're going to write this one off to the side. This is how we started off this chapter. I'm going to scribble it out up here, And now I'm going to scribble out one of these letters, either the X or the Y. Looking at this, hopefully you can see it. I'm supposed to scribble out the Y. I'm going to rewrite it so it looks a little bit nicer. And I'm going to put, instead of Y, X plus 1, because that's what it says Y is equal to over here. Okay, hopefully this is coming back to us a little bit. So I get negative 3X plus 5X plus 5. Okay, again, this is what we did at the beginning of this chapter. And then I can put some stuff together here. I end up getting 2X plus 5 is negative 17, minus 5 on both sides, and I end up getting 2X is negative 17 plus 5 is 22. And when I divide both sides by 2, I end up getting X is negative 11. So that was a little bit more work than elimination, but now this is pretty easy. I just need to take this negative 11 and plug it in right up there. And I end up getting negative 11 plus 1, which is negative 10. So now my coordinate is negative 11 comma negative 10. And that's substitution. So the next two on the next page are going to be ones that could really be solved either way. All right? So if you really, really like elimination, you could do it. If you really, really like substitution, you could do it. We learned how to do this one using substitution. I say here we typically use substitution when one of the equations has a variable all for itself or all by itself. While in this one, both of them have something all by themselves. This top one says y equals, and so does this bottom one. So using what I just learned on that last one, or just reviewed on that last one, I'm going to write one of those off to the side. And remember, the reason I'm doing that is I'm going to plug back into it. So which one would you rather plug back into? Well, obviously this bottom one that says x plus 1. So I'm going to rewrite this top one, after I scribble that one out, is negative 2x plus 10. And I'm going to put this y right there. So it's now going to say x plus 1. So now when I try to solve this, what should I do if they're on both sides like that? Can I put them together and say negative 1x? Well, obviously not. They're on opposite sides. I'm going to add 2x on one side. And if I add 2x on this side, does everyone see why I added 2x and not minus 1? Then I end up getting 3x plus 1 is 10, which should be super easy for all of us to do, because now I can just minus 1 on both sides, and I end up getting 3x is 9. Divide both sides by 3, x is 3, plug back in up here, and I end up getting 4. So my coordinate is 3 comma 4. Now, I had this one on these notes because I said you could really do it either way. How could I do elimination on this one? Now, I'm not going to go full out and do it, but I just want to practice. How would I get rid of the x's? What could I multiply this bottom one by if I wanted to get rid of the x's? Well, obviously I could multiply it by 2, end up making, I'm going to write it up on top here, 2y is 2x plus 2, and when I add them together, I end up getting 3y is 12, which looks pretty darn similar. Wait, 3y, yeah, 3y is 12. And down here it says y is 4, which divide both sides by 3, and we end up getting y is 4. Okay? So we end up getting the same answer if we do it that way. All right, so let's take a look at example 4. Again, this is one that could really go either way. The terms are lined up, so I would typically do elimination. But one of the variables is really, really easy to solve for. So again, I could multiply this one by something to get rid of the y's. What could I multiply it by to get rid of the y's? In fact, I think you could even get rid of the x's here, couldn't you? But anyways, to get rid of the y's, I could multiply it by 2. If I wanted to get rid of the x's, I'd multiply it by negative 3. But if I wanted to do it using substitution, couldn't we solve for x in this guy? And it's been so long that we've done substitution, and I want to practice doing that again. So let's solve for x in the bottom equation. What was so special about that x in that bottom equation? Why is that one really, really easy to solve for? Well, obviously, there's just a 1 in front of it, so it's really, really easy to just minus 2y on both sides and end up getting x is 2 minus 2y. Right? So now it's just like those ones up above where I cross this out, I rewrite 3x minus 4y is 26. This is the last one, guys, and then you're going to work with each other here. I'm going to get rid of this x and get 2 minus 2y to get 6 minus 6y minus 4y is 26. Almost done. I end up getting 6 minus 10y is 26. Minus 6 on both sides. I end up getting negative 10y is 20. Divide both sides by negative 10. And I end up getting y is negative 2. Plugging that back in right up here, I end up getting 2. These two together, negative 2 times negative 2 is positive 4. And I end up getting x is 6. So when I make my coordinate, I end up getting 6 comma negative 2. Again, if you would have done that one using elimination, you would have gotten the same answer. So on the last page right here, I just have a couple final thoughts. When the terms are lined up, use elimination. That's my tip. I didn't on the last one just because I wanted to review how to do it using substitution because it's been a while. We've spent the last couple days doing elimination. And then use substitution when a variable is solved for. So that's it, guys. Thank you so much for watching.